Good morning, everybody, from my side. My name is Michael Rescher. I'm the chairman of the Gauss Centre for Supercomputing, the German national high-performance computing infrastructure responsible for running high-performance computing in Germany. I welcome you to this special session. The purpose of this session is to introduce a little bit the strategy of the Gauss Centre for Supercomputing, especially with respect to the hotly debated EuroHPC activity, the joint undertaking that is in Statuna Sendi, so it's born these days, weeks, months. And a lot of people have asked, so what is the German position? Where are you headed? What are you going to do with this? In my talk, I will briefly introduce the Gauss Centre just to set the stage for those of you who are not friends and colleagues of the Gauss Centre, for you to better understand what's behind this German strategy. I will then announce how we are going to work with EuroHPC, which of the centers, of the three centers, is going to hand in a proposal for being a hosting entity. And I'll say a few words about applications that are relevant for us, and keep that in mind. Applications is everything that drives HPC. It sometimes gets forgotten, and that's why we want to remind you of that. So my first question for you is, what is the Gauss Centre for Supercomputing? Some of you met us last year when we celebrated our 10th anniversary, so we were obviously created in 2007, and at that time the idea was to have a single center, and what we have is we are an organization that is funded by the federal government of Germany and by the three state governments of the states of Baden-Württemberg, Bavaria, and North Rhine-Westphalia. This is one of the key features of German HPC. Sometimes it is considered a weakness because you have so many decision makers, but on the other hand it is a big strength because we have the support of four governments, not only financially, which is highly welcome, but also politically. So each of the centers is deeply rooted in the state organization and has both this regional focus and a national focus. So that's one of the strengths of the Gauss Centre for Supercomputing. When it comes to discussions with Europe, sometimes that means that we need to coordinate a little bit more than other countries. More centralized countries certainly don't have that problem. But we like it, because Dieter, Thomas and I love to meet and chat a little bit and make decisions about how we do HPC. It's a collaboration, as you have figured already, of three centers. The three national supercomputing centers in Germany. That has a long history. It goes back 28 years or so when Germany decided to have national centers. And then these three centers came up with a proposal for being national centers: High Performance Computing Center of Stuttgart, HLRS, and then the Jülich Supercomputing Center, and then Leibniz Computing Center, as it's called. I keep saying that LRZ is at Munich, but to be honest, it's at Garching, which is close to Munich. But Munich sounds much better for those who are not Germans. The focus of these three centers is to be a European center. So we are one of the key partners in the PRACE activities since the beginning of PRACE. For a long time it was one system in France, one in Italy, one in Spain, and three in Germany. So we were like 50% of PRACE. So playing an important role within PRACE. Now that Switzerland has joined, we have lost sort of the majority in a sense. But it's okay, yeah. And certainly we are in charge of providing tier 1 capability in Germany, so we are responsible to make our scientists in Germany happy. Go ahead. What are the main driving forces? The most important driving force for us is science. Scientific uses, their applications. You will hardly ever see that any one of us shows a big interest or any affection for peak speed. Peak speed is nice, but it doesn't solve any of the problems. So what we try to do is, everything that we do is driven by our scientific community. Everything is driven by their demand. That means all our procurements are driven by the requirements and demands of our users. That leads to the situation where each center has a clear focus, and each center has a hardware-driven, an application-driven hardware strategy. Just to give you a rough idea, Jülich you will find in the Human Brain Project. You will find it in basic research. Yeah? And because Jülich is working with applications that are happy and can exploit most recent technology, even bleeding-edge technology, you will very often find Jülich having systems that are bleeding edge, more experimental, more trying things out, more taking risk. Yeah? Munich is our center that is focusing on geophysics, astrophysics, but also on general purpose capability of high performance computing. So you will find systems there that are more stable in a sense, less bleeding edge, although they are working on innovations, for example in cooling technology and other similar things. And finally, you'll find Stuttgart to be in charge and responsible for engineering applications, and we're also working with industry, making our systems available to industry. So we make sure that we have very stable hardware. We make sure that we have proven technology. We don't want to go bleeding edge. We don't want to go bleeding edge because our researchers see simulation much more as a production activity rather than a research activity in itself. They don't want to try out whether the system works, they want to do their CFD simulations. Yeah? So this strategy works out pretty well in the sense that we have Jülich as a pathfinder, we have Munich as a very stable in the middle center, and we have Stuttgart as the center that bridges the gap between bleeding edge science and industrial everyday usage. Yeah? By doing this, we can actually span this range of science, groundbreaking, high-risk science, applied science, close to development science, to the point where companies like Porsche are using the systems in their everyday business. Yeah? Sometimes this is again challenging, so I'm talking about the challenges of German supercomputing here a little bit. But it is also rewarding, and what is good, it gives us a very positive story for all the decision makers in politics. Because regardless of whether they are more interested in Nobel Prizes or more interested in supporting their local small and medium-sized enterprises, we can deliver on their requirements. Yeah? And by doing so, we can take a leading role in European HPC. Now, funding for the Gauss Centre of Supercomputing is difficult to explain. I will not try. Yeah? People in the first row keep smiling, and our accountants are back in our offices and keep track of the money. But I will try to explain to you a little bit why we are working in projects and what we did in projects. So the funding for the first phase of Gauss was in a project-driven strategy which was called PetaGCS. At that time we were talking about petaflops. That was the transition period. We started back in 2008 and the project is running until 2019. Actually by the end of 2019 we will bring down the last system that was funded through this PetaGCS project. The total funding was 400 million euros, so it was 133 million for each of the centers. Each of the centers are bringing in 2 systems over the lifetime of the project, such that basically every year we would have a new system. The 400 million euro were raised by the federal government, half of that, and the other half was raised by the state governments. Now, continuation is done in a project which is called CWGCS. Now I'm looking at my manager and I told him that we need a better acronym, but this is what we have. I don't know what it stands for, but I think it has to do with simulation and it has to do with availability of supercomputing systems. Thank you. I get a thumb up. That project started back in 2017, so that's when we started on our procurements and we started to work on operational issues. But we also started to work on something which became more important over the last years, both federal government and state governments understood it's not only about the hardware, it's also about the people. So 1.5 years ago we started to hire people to improve the support for our users, with a special highlight on making sure that our users get simplified and unified access to all of these resources. So if you apply at Jülich, you can also move to Munich, or you can move to Stuttgart. And on the other hand, improve training and increase training activities. The Gauss Centre is so far the biggest training center in Europe, with about 2,000 people trained in HPC every year. And then a new strategy for industry, not just using systems at Stuttgart, but rather sort of rolling out that strategy all over Germany, potentially even to Europe. So we are already working with the people. The project will run until 2025, and it'll probably be extended depending on the lifetime of our systems. The budget is slightly higher, 460 million euro, which gives every center now 153 million euro. Part of that money goes into central organization, but very little. We are Germans, we try to save on bureaucracy, and we try to spend everything for the real thing. Again, half of the money comes from the federal government, and half of the money comes from the 3 state governments, and we appreciate that. What we figured over time is that we have to closer connect technically. That means networking, and that means access to data. So the federal government was so kind to bring in a new project, which we call InHPC. It is officially funded by the federal government, but all the state governments support their centers to make sure that we get access to 100 gigabit or even 200 gigabit connections at each of the centers, such that the 3 centers are well connected and users can move data around. I will not talk about technical details here because this is a talk about strategies. Funding for this is 50 million euro, and we have to be done by 2021. We already started to connect our centers. You will see that we bring in new systems. Jülich system is already there and is operational. Munich system will come by, I think we will see it on the top 500 lists in November, right? Yeah? Yeah, okay. So we will continue to do this, and we will make sure that we have a single source of data in these 3 centers, where it doesn't make any difference where your data are and where your supercomputer is. You can run your jobs wherever you like. Now within Beta GCS, this was our development. We had Eugene, we had Supermop, we had Hazelham. So these were the 3 names for the systems. And what you see in the back is our ranking in the top 500. And you see Jülich was number 2, Munich was number 4, and Stuttgart was number 8. And that's exactly what I described in my strategy. Bleeding edge, so you have to be number 2 in the world, or maybe number 1, but we didn't make that. Then more stable, so you're number 4, and then okay, it can be used by industry, so it's only number 8. So over the time of Beta GCS, we had a fairly good positioning in the top 500 list. Now unfortunately, over the last 1.5 years, there was a gap between the old project and the new project, so we're not looking that well in the top 500 list. And when you look at the current top 500 list, the fastest German system is number 23, but it's only the first step. And we will see this getting better. Now what do we do in CW GCS? We will see new systems. As I said already, there is a new Jülich system. It's called Joules. Jülich is always using names with Ju, standing for Jülich. The supplier is European. It's Atos. The processor supplier is a company from the US, if I'm not completely wrong. Yeah, it's Intel. The EPI, the European processor, is not yet there, so Jülich has to make do with an Intel processor. It has relatively moderate performance because it's the first step in a modular concept, where Jülich says, okay, we build up gradually over time. It's only 122,000 cores relatively. It's 1 million GPU cores. So you see it's a mixture of CPU and GPU, taking more risk for users who actually need this technology. It has a GPFS file system. And as I said, it's the first module of a modular concept. And next year, we will see something, Thomas told me, more than 50 petaflop. So now, Thomas, you are sort of hooked to that. If you deliver only 49, everybody will complain. But fortunately, you said 50 plus and not 50 plus plus.
I have to interpret what plus means.
Yeah, I mean, considering your age and my age, you probably mean like 54 and not 58. Okay, so this system will be higher up in the list and will give performance to the users of Jülich in the coming years. LRZ is not yet at the point to participate in the top 500 list, but they have made a decision, they have signed a contract. Their supplier is this small US company, Intel, supported by another company, which is Lenovo. Lenovo is international, as I was told. It's a 26.7 petaflop peak performance system, and it has around 300,000 cores. So you see, we're gradually building up our capabilities. Now, Jülich has installed. Munich will go operational before top 500 November 2011, and Stuttgart will work on a system to be available end of 2019. Maybe early in 2020, that may depend on the roadmaps. We're currently in the procurement, so I cannot give you any estimates or numbers or anything about that, but it will be a relevant and big system when it will be available end of 2019. So the strategy again is working with these three systems. We will be in the top 10, top 15 in the world, and we will make systems available to our users that nicely fit their requirements. So if that strategy is working, why do we need Europe? That's a good question. So here is the Gauss Centre strategy. I mean, everybody would say, well, if we go to Europe or if we go European, then there is more money. Yeah. That's certainly one argument. I have never met a director of a supercomputing center who said, oh, please give me less money. Yeah. That's very rare. If you know of anyone, just let me know, such that I can quote the guy. Yeah? But okay, that's an incentive. But there is more to this. The strategy that we have here is taking sort of a global view of what we are, the environment in which we are working. Now, when we look at the German level, the German government has decided to set up something which they call the National High Performance Computing Resource, NHR in German. Yeah? This is supposed to cover the needs of German researchers at the level of Tier 2. And Germany is trying to sort of consolidate, not to have too many organizations, but bringing all these things together. Now, as German national centers, we have to take care of this, we have to consider this, we have to collaborate with NHR, we have to collaborate with the Tier 2 centers. So we have to look, in a sense, we look down when we think about this pyramid of performance, where at the top you have Tier 0 and then Tier 1 and then Tier 2. So in a sense, we have to look down and we have to say, okay, we need a broad base of users, we need to collaborate with the smaller centers in Germany, we have to make sure that this ecosystem in Germany is working. On the other hand, we fully understand that we need Europe to be able to compete in the race for the exaflop. When we look around, we see there's a Japanese strategy, there is a Chinese strategy, there is a US strategy. Now, Germany is not such a small country. I say this as an Austrian, which is much smaller. Germany is not such a small country, but we don't have the same financial capacity as, say, the US government or even the Chinese government. And Japan has a special situation because it has 3 HPC vendors, so they have sort of a need to support their economy. So going European means this is the way to move forward into the age of exaflop computing. So we have to look at these European developments, we have to blend in with them, we have to collaborate with the other European centers. There are many. Yeah? I count at least something like 15. So we have to deal with everything that happens in Europe, and we have to see how we fit into that. So in a sense, we look upwards to Europe, downwards to the German ecosystem, and we have to be somewhere in between. This is not a trivial activity, because the needs and the requirements of these two communities are different. In the European arena, what you're talking about is true bleeding edge international competition at the highest level, talking about could we be number one, could we be number two, could we be number three. So it's all about speed. It's all about speed also in delivering performance for your users as early as possible to be visible. When you look down, it's all about continuity. It's all about making sure that the guy who is working on a tier 2 or tier 1 system in Germany, when he comes back in 1 year with a new idea, there is still the ecosystem there. So we have to work with a system or a configuration that is targeting like Formula 1, or you could even call it the half-a-mile race that you see in the US. While when you look down, you say, okay, this is long-term activity. This is using the A8 from Stuttgart to Munich and handling the traffic in your 300 horsepower car, but everyone going at a speed of 120, or even worse. And being able to handle these two different ecosystems is not so easy. Yeah? So we have to define a strategy where we say, okay, which role do we play? Which role do we want to play in Europe, and which role do we want to play in Germany? I'll not go and talk about the role that we play in Germany in every detail with the national high-performance computing infrastructure. We will have a discussion with those people on Friday. But I'll say a few words about our strategy for exaflop computing and about our strategy and how this blends in to EuroHPC. Now, Professor Lucas last year announced what was called Smart Scale Strategy. That's basically what describes perfectly what we are trying to do. Not focusing on exaflop, but on exascale. And by exascale we mean that we don't look too much at the performance level, but we rather look at what kind of solutions can we get with that level of performance. So it's still exaflop at a certain point in time, but that's not the focus. And by smart we mean it's more than hardware. It's software, it's people, it's the environment, it's the collaboration, it's the co-design of applications and hardware. Yeah? So roadmaps look like this. We started this last year. We want to bring in a first exascale system, pre-exascale system in 2020. Yeah? That could be European, by the way. We might consider to be a candidate for a pre-exascale system because that would fit nicely into a German strategy. We may want to team up with other European countries in that, but that's interesting for us. And 2023 we want to come up with exascale solutions, and that means not only one of the centers, but over time all the three of the centers. Making sure that this strategy of pathfinding, stable general purpose engineering industry keeps moving, and we don't widen the gap between high-end bleeding edge and the normal world. Now that means we would like to achieve a few things. Our objectives are to provide integrated solutions, hardware, software, to increase our application performance mainly and not our peak performance. So we want to be a factor of 1,000 faster. We want to have high-quality HPC services and an ecosystem not only in terms of hardware, software, people, but also in terms of tier 0, tier 1, tier 2, tier 3. In the state of Baden-Württemberg we have a project where we bring down tier 0 to the level of tier 3, so clusters at universities. And training is a big issue for us, because if we don't train people, then the systems are wasted. We see it today. We keep pushing our users, we keep training our users. Still everyone who comes in anew has a learning curve, so we're wasting CPU cycles on that, so that's rather important. And then we are working also on leading application performance and, Munich for example, energy to solution. Realization systems with an integrated performance above 100 petaflops from 2020 on mobility programs for users. We want users to go to the centers. We want to be in closer touch with our centers. We want to do code porting, supporting them in optimizing their codes. Application enabling. We have interesting applications that require HPC, but those people not fully understand what the needs are for them. Communication and dissemination is something that happens, for example, here today. And finally, new types of access. And this is how we try to blend it all in. Currently, we have three things going on. One is the EuroHPC activity that is closely linked to EPI and to the centers of excellence. So you see EuroHPC, the systems, EPI, the processor, COE, the applications. And this is currently targeting pre-Excel. So that's what we will see in 2020. The European Union and a number of member states are headed toward creating EuroHPC. We will see a call for participation. We will then see a decision about who is going to have a pre-exascale system. As I said, Germany might want to participate in that, to have a stepping stone towards exascale. On the other hand, we have sort of more traditional approaches in Europe. PRACE, the European Open Science Cloud. These are not so much hardware-driven, not so much solution-driven. This is more about providing certain services, certain access. The question will be how we get PRACE into EuroHPC, how these things will work together. And we have so far, as you have heard, CWGCS in HPC and other federal-funded projects like SPPXA, which is a federal project in Germany to fund the development of software. Now what we will do is we would like to bring all of these three together to have a first exascale system. And we are suggesting to Europe and to our partners that one of the exascale systems of EuroHPC will be located at Jülich, because Jülich is the natural location for such a system. Be the first, be bleeding edge, work with the users, accept that you run into some problems at the beginning, that you are the pathfinder, that it is difficult, but these guys at Jülich are used to that, and then Stuttgart and Munich will follow. To set up an exascale approach that covers all the three countries, all the three states, all the three centers, yeah, and the full range of scientific applications from basic research down to applied research and industrial usage. Now just a few words about applications. I'm running out of time here, but it was more important to give you a message about the strategy rather than showing fancy pictures. So a few applications here. We have more than 300 scientific large-scale applications running on our systems. A typical one for Munich is seismic wave propagation. We will try to increase the speed of this application by a factor of 1,000, so we end up with an exaflop. A typical one that we see here is noise reduction of ventilators. That was done, by the way, in Stuttgart and in Jülich. So that's close to engineering, but at the same time it is basic research. And this is my favorite one. Yeah, you see it moving. Because this is nice. It makes political sense. People look at it and start to understand what's happening. This is precipitation. It's a simulation on a 6-hour basis for several months. But when you look at it carefully, you see the granularity of it. It's 50 times 50 kilometers. So you will need a factor of 1,000 to actually turn this into a reasonable simulation. It was done by guys from the University of Hohenheim. Okay, what I tried to tell you is Gauss is there to cover German and European HPC and bring these together. Gauss has a strategy for national supply of HPC. We want to merge this with the European strategy of supplying European research with access to exascale systems. We have decided to have Jülich as a candidate to be the place where we see the first European exaflop system, and we will bring in LRZ and we will bring in HLRS to continue a strategy of a balanced system of 3 centers, providing the whole range of architectures to the whole range of scientific applications. With this, I'd like to thank you, and if you have any questions, you are highly welcome. Thank you.